Hello class, good day sa ating lahat. So for today, pag-uusapan natin on how to design singly reinforced beams. So but before that, uh, introduce muna natin yung mga codes and mga formulas na gagamitin natin in designing our singly reinforced beam. So here, first is our NCP codes of our load combination, di ba? So medyo familiar na tayo nito kasi nung prelim, nag-topic tayo ng one-way at two-way na beams, di ba? So, ng one-way or two-way na columns. So, na-introduce natin doon yung different NSCP loads natin. So, if we are talking about 2001 NSCP, so ito yung mga load factors natin, yung combinations or load combinations, di ba? Na-topic natin yan that we need to have a factor of safety in designing our slabs, beams, columns, and etc. So, therefore, our national code or national structural code of the Philippines, binibigyan tayo ng factor of safety. Pinapalaki natin yung mga loads natin like just like our dead load, live load, wind loads, and earthquake loads. So yan po yung purpose niya. So if you're talking about 2001 NSCP, so ito yung mga load factors natin. Ito yung palaging nagagamit, 1.4 dead load plus 1.7 live load. But for today, lalo na sa ating board exam, ang ginagamit natin is 2010/2015 NSCP. So if we are talking about 2010 and 2015, medyo hawig lang talaga sila. But if we are talking about 2001 and 2010, medyo marami na talaga silang agwat. Here, for example, no, binigay ko lang dito para what if makasalubong kayo ng problems na 2001 NCP pa yung gamit, no? So, medyo familiar pa rin kayo sa codes na gagamitin o yung load combinations na gagamitin. So, as you can see here, ito yung palaging nagagamit, 1.4 dead load plus 1.7 live load. Pero pagdating natin sa 2010 or 2015 na National Structural Codes of the Philippines na code is that gumagamit na tayo ng 1.2 and 1.6, 1.2 and 1.6 na live load. Ayan siya. And dito rin, no? 1.2 and 1.6 na live load. So 1.2 dead load, 1.6 na live load. So, no? Siguro na-analyze, no? Nakita siguro ng mga ating mga structural na mga engineers, no? Yung gumagawa ng codes natin na medyo mataas lang yung medyo dako ra kayong factor, malaki masyado na factor yung 1.4 tsaka 1.7. Siguro super safe na talaga yon, no? Hindi na siya economical. What I mean is that malaki na masyado yung factor of safety, therefore napakalaki na din yung mga sections natin. So therefore, ang ibig sabihin pag malaki yung sections ng ating columns, beams, slabs, malaki na din yung ating kailangan na budget. So therefore, na-analyze ko nila na medyo exaggerated lang yung ating factor of safety. So niliitan nila from 1.4 dead load naging 1.2 dead load. Yung 1.7 live load naging 1.6 live load. So therefore, na safe pa din siya pero mas lumiliit na yung ating cost sa ating construction kasi naliliitan na din yung ating sections ng ating slabs, beams, and columns. Anyway, so ayan, no? Para maging aware kayo na meron 2001 and meron din tayong 2010 na factors. Okay? So, pagdating naman sa ating design strength, no? Meron din tayong mga kaibahan pero maliit lang man din ito na mga differences. For example, sa flexure, if we are talking about 2001 and 2010, same lang sila, which is 0.9. Sa compression, 0.75, the same lang sila. So dito lang sila nagkaiba sa other compression controlled sections. So 0.7 and 0.65, 0.85, 0.75, no? More on pinapaliit talaga, no? Dito pinaliitan nila yung ating mga codes kasi malaki lang siguro masyado na realize nila. Okay? So punta tayo in designing our singly reinforced beam. Ayan po. So this is our diagram. Paano nabuo yung codes natin o paano nabuo yung ating mga formulas sa pag-solve sa area ng steel na gagamitin natin sa ating beams itself. Okay? So for example, here we have the cross-section of the beam. So BW states the width of our beam then hour, hindi nakalagay dito, no? So, minsan nilalagay nila H or total height, 'di ba? Kasi pag D, that is the effective depth, 'di ba? Same pa din sa ating slab, 'di ba? No, topic natin 'to. Effective depth, ang ibig sabihin po niyan is from the top of your beam papunta sa center of gravity ng ating reinforcing steel. So for example here, no, kasi dito sa figure natin is we have double layered na bakal o ng reinforcing steel. So therefore, yung center of gravity nila is nandito, na i-solve pa. Kailangan mo pang i-solve yan. Pero, for example, no, para mas madali tayo, for example is hindi siya single layered lang siya. So for example, dito lang yung bakal niya. So therefore, yung kanyang center of gravity is nasa gitna. No? Siguro naman din sa ating board exam, medyo easy lang yung binibigay. So mga single layered lang yung binibigay natin. So therefore, na para madaling i-solve, from the top or outermost natin na layer ng ating beam papunta sa center of gravity ng ating reinforcing steel. Ayan, that is our D na ibig sabihin is effective depth. So topmost papunta sa center of gravity ng ating bottom na bars. Okay, so with that, no, this is NCA, no, medyo karat lang siya or medyo na blur lang siya. So that is NA, no, neutral axis natin, NCA, NA. Okay, so first thing, meron tayong tinatawag ito na strain diagram. What is the definition of strain? No, that is a deformation in every length. Yung pagka-deform ng ating area in every length or measurement. Diba? So therefore, if we are talking about strain is unitless siya. Or minsan it's millimeter per millimeter. Diba? So ma-cancel out siya, unitless. Basta yung ibig sabihin ng strain is yung deformation per length. So pwede millimeter per meters, and etc. Okay, so if we are talking about our strain, if we are talking about our deformation, so as you can see, no, this is our graph. Habang lumalayo tayo sa ating NA or neutral axis, lumalaki yung ating deformation. So let us just assume, no? So dahil sa loads na nasa itaas, what will happen to our beam? No? Mag-deform siya, for example. No? So for example, compression siya. So mag-ano siya, no? This is just an example class. This is just an exaggeration. No, hindi naman siguro makikita talaga yung strain natin kasi maliit din masyado. So ganyan, no? So as you can see, yung nasa pinakaitaas at yung nasa pinakamailalim is malaki yung deformation niya or strain if we will compare that one sa gitna. So therefore, pag itatanong sa inyo, what is the deformation, what is the strain in the middle or in the neutral axis of our beam, that is 0. No? So as you can see, 0 siya sa gitna na, then lumalaki siya as it goes upward or sa ating outermost na fiber. No, what is fiber? That is fiber. No? One line fiber. No? Siya gamay. Maliit na strip. That is a fiber. Then same din sa baba. Habang lumalayo tayo sa ating neutral axis is lumalaki yung strain natin. So this is our strain diagram. No, that is epsilon. No, that is denoted as Greek natin letter which is epsilon. So epsilon C, which is our compression, P is for tension. So pag-usapan natin yan. Bakit sir sa itaas is compression, sa baba is tension? So for example, class, we have our beam. Ayan. Then this is our cross-sectional view. Then this is our side view. Ayan. So class, if you have a load there, no, concentrated load, for example, this is may nakapatong sa kanina na live load and then it's self-load or dead load. Anong mangyayari sa ating beam, no? Our beam tends to have a figure or yung output niya na mag-smile siya. This is exaggerated, hindi naman siguro ganyan talaga yung ating deformation. So mag-smile siya, class. Na mag-smile, na mag-bend, di ba? So therefore, pag nilagyan natin yan ng neutral axis, ayan, sa gitna, mahati siya into two regions. No? So this is our top view. Ayan, hatiin natin. This is our neutral axis. Sa top natin na fiber is that is in compression. No? Na didiin siya. No? In compression siya. Meaning, for example, I have an example here, no? A notebook, for example. If you will bend this notebook, as you can see, yung nasa topmost niya is nako-compress. Diba? Imagine natin, this is your beam, no? Medyo napakaliit lang niya. So if we put a pressure or a load sa itaas niya, no? Mag-bend siya. So yung half niya, other half from the middle pataas is in compression, no? Nadidiin siya. While yung another half naman is in tension. What is tension, class? No? Mainat. Anong Tagalog ng inat? Mahila siya yung kanyang mga tendons. So here, no, ulitin natin to. Erase. Ayan. So if we have our section, ayan. And then lalagyan mo ng load. Diba? Ayan, this is your load. Yeah. And then yung sa baba, ilagay ko lang yung kanyang cross-sectional view. So therefore, coming from our load, no, so mag-bend yung ating beam. And from that, no, ay hati natin sa dalawa. Sa top is in compression, sa bottom is in tension. So therefore, no, na-separate siya, compression and tension. So if you're talking about our strain, sa top is yung ating epsilon T, meaning in compression siya. Sa baba is epsilon T, or is in tension. Diba? So I hope that you can imagine, no? Yung fiber na dito is nadidiin, na-compress. Sa baba naman, lagyan natin ng arrow. No? Nag-compress siya, papasok. Diba? Ayan, na-compress. While sa baba is in tension, no? Na-bend siya. No, nahihila siya yung kanya mga fiber. So therefore, yan yung lagi natin tatandaan. Kung saan nag-act yung ating load, no, it is divided into two parts, compression and tension. Okay? So balik tayo daan, no? I hope that you can still remember that, compression and tension. So, balikan natin to. For example here, no, sabi natin kanina, paano natin sukatin, diba? So from the top papunta sa ating center of gravity ng ating bottom na tension part ng ating reinforcing bars, that is our D or depth. So pag double layered, so therefore nasa gitna talaga. If single layered lang siya, so therefore nasa gitna ng ating bars. Okay? So how about this one? No, this is the diagram of our strain, diba? So ito yung tinatawag natin na C. No, that is small letter C, ha. Kasi mamaya meron tayong capital or caps lock capital na compression or na letter C, that is our mamaya na yan, no. So ito, pag hinahanap what is our C or yung ating length, that is ang definition niya is from the topmost natin na fiber papunta sa ating neutral axis or saan or kung saan wala tayong strain. That is our neutral axis. Okay. So next one is our stress. What is stress? Force over area. Now that is your force na nandiyan divided by the area. So therefore, this is our stress diagram. Diba? As you can see, if you have a load here sa itaas, medyo wala ng stress na idudulot sa may baba na part. So therefore, sa neutral axis lang dyan, zero na yung ating stress. Diba? Lalo na sa itaas, no? Dito is hindi masyadong stress, pero dito na part, that is our FC prime, that is the most stress na part ng ating beam. So this is the diagram for our stress. Okay. So, but a scientist, I don't know if this is a scientist or an engineer, no? Si Whitney Houston, no? Joke lang. So Whitney yung kanyang last name, no? Kasi pag ganito class, mahirap yan masyado i-solve, di ba? Kasi wala siyang definite na tawag dyan na shape, di ba? So, ang ginawa ni Whitney, no, para for the sake of solving or for the sake of designing our beam, so ginawa niyang rectangle yung ating stress diagram. So, sabi niya, para ma-equal natin maging uniformly distributed yung ating stress, i-multiply down natin ng 0.85 yung ating FC prime. What is FC prime? Na-lesson natin yung ating one-way at saka two-way ng slab. That is our strength of our concrete. Diba? FC prime. Okay. So, balikan natin yan. Sabi ni Whitney, para madali siya i-compute or for the sake of our computation, ang gagawin na lang po natin is i-multiply ng 0.85 yung ating FC. So, ito na yung height ng ating stress diagram. Okay, so how about the height? Kasi naging uniformly distributed na siya. So therefore, yung height natin na from the top papunta sa neutral axis is mag-iiba. So ang height daw natin class is denoted as A, no? This is our compression block. Baka minsan when you're solving or sa board exam nyo mismo, may nakalagay, what is the height of the compression block of the beam? So this is our compression block na height. So therefore, this is subjective to compression na stress. So therefore, yung nasa baba, wala na pong stress na nandyan. According to this one, di ba? Tension na lang yan, etc., etc. Basta, you get it. Okay? So, the height of our compression block is equivalent to beta times C, which is our C kanina is this one, di ba? So, beta times C. So, mamaya, we will tackle about our beta. So, nasa NCP natin yan kung ano yung values ng ating beta. Basta tandaan nyo, beta times C. That is the height of our compression block. Okay, so, sa ating statics or sa ating tawag dyan, theory of design, theory 1, theory 2, di ba? So, we need to balance this one, no? Kasi everything must be in balance if we are designing. So, therefore, in order for us to balance this one, is ginagawa natin point load, di ba? From uniformly distributed load, ginawa nating point load. So, paano gawing point load si uniformly distributed? That is just the area of our rectangle. So therefore, area natin is, this is our height, 0.85 FC prime, multiplied by our height. Ito. No? So that is A times, C natin is 0.85 FC prime, ayan siya, multiplied by our A. Okay ba? So therefore, pag ganyan, no, multiplied by our B, or yung ating base natin. Diba? Kasi yung A natin, then per unit length tayo, or per B length, so therefore, multiplied by B. Ayan. So, saan galing si B? Ito yung B natin. So, that is our capital letter C. That is the force coming from our compression na block. Okay. So, therefore, ayan that is our compression force. Diba? Sabi ko kanina, wala tayong compression, wala tayong stress sa baba. So, how can we counter this one? Diba? So, ang ginawa ng ating mga engineers is nilalagyan nila ng bakal sa ibaba in order for us to have a force sa baba to equal the force na nasa itaas. And that is our tension. Tension bars natin yan. So, coming from these tension bars, take note na yung ating yung ating concrete, no? Wala siyang resistance when it comes to tension. 'Di ba? Kaya nga nilalagyan natin ng bakal or rebars para magkaroon tayo ng tension. So coming from these rebars, nagkakaroon tayo ng tension. So tension natin is area ng ating steel, area ng lahat ng steel na nasa ibaba, multiplied by our Fs. What is Fs? no? Minsan yan is Fy, same lang yan ni Fs depending upon the situation. That is the strength of our reinforcing bar, no? No Fs ng 415, 275 MPa, megapascal, yun yung strength ng ating steel itself. Okay? So therefore, balance na yung ating equation. Diba? So what is the distance between the two? That is D minus A divided by 2. Saan yan galing? This is our total depth. Ayan. Assuming na we have double layered, no? Basta, ang definition ng D ha is from the top papunta sa center of gravity ng tension bars natin na nasa ibaba. Ang tension bars nasa baba talaga. Okay? So, D minus yung half ng ating tawag yan, height ng ating compression block, which is A divided by 2. So therefore, yan, papunta dito is D minus A over 2. Okay, so with that, class, ayan, no, that is, no, nilagyan na niya ng moment, that is Mn. That is caused by our C na dapat kailangan natin yung ating tension para ma-equal siya. Diba? At para summation of moment is equivalent to 0. Diba? Take note, lahat ng moment, lahat ng forces dapat ma-equal to 0 para static siya. Para walang movement sa ating structure. Kasi pag meron, what will happen to your structure? It will fail. Hindi naman talaga fail. Para pag hindi kasi 0 is, there is a movement because meron pa tayong force na hindi na equal. Okay? So I think that's it. Puntahan natin yung ating mga formulas. Ayan siya. So, medyo mahirap to if we will discuss this one by one talaga. So, mas maganda if lagyan na natin ng konting concept and then memorize na lang natin. Dapat alam lang natin kung kailan natin gagamitin yung mga formulas na nandito o yung i-discuss ko. So, beta. Yan ang sabi ko kanina, B. If you're talking about 2010 NCP, that is 0.85. If our strength of the concrete is lesser than or equal to 28 megapascal. But if it is greater than 28 megapascal, yung strength ng ating concrete, yung ating beta is mag-iiba. That is 0.85 minus 0.05 multiplied by FC prime minus 28 divided by 7. And then, sabi din dito sa code, dapat din na hindi bababa ng 0.65. For example, malaki na masyado yung ating FC prime. For example, is 70. So therefore, pag ganyan, no, maliit na yan masyado yung kalabasan dito, siguro mga 0.5, 0.7. So hindi naman din pwede na maliit masyado. So sabi ng NCP, oops, limit ka lang sa 0.65. Okay? So yun, tatandaan natin. Tingnan mo si FC prime. If it is lesser than 28, pasok siya, 0.85 gamitin mo beta. But if it is greater than 28 megapascal, ang gagawin natin is to use this formula. So therefore, pinapalitan natin si beta as your FC prime ay lumalaki. Okay, so how about Fs? This is Fs. This is the strength of our steel. Reinforcing steel natin. Itong kable, kumbaga. So, Fs is equivalent to Fy, di ba? When the steel yields. Meaning ng the steel yields, meaning nauunang nag-give up. Oh, ang sakit. Nauunang nag-give up si steel before kay concrete. Di ba? Take note, class, na ganyan. So, just remember that one. Okay, so Fs prime when steel yields. So, therefore, if that is the case, yung ating strain ng ating S, no, yung strain natin is greater than yung strain ng ating tawag dyan, bakal mismo. So, ES is strain ng ating concrete. Hindi. Yeah. Yun. ES then is greater than EY. Okay. So, therefore, still yields. Therefore, we can use our area of our reinforcing steel na. Okay, so how about if Fs is equivalent to our modulus of elasticity ES times RES? or that is still does not yield. So, if our still doesn't yield, meaning hindi siya nag-give up, di ba? Before sa ating concrete. So, ang ibig sabihin yan if yung ating strain is lesser than yung strain natin ng EY. No? So, ganun yung ating, mamaya, madi-discuss natin yan medyo no, na nalito tayo doon, di ba? Okay, so basic general relationship natin from the strain diagram. So, I hope that you will watch another video for this one. Na-explain doon on how to derive this one. Di ba? So, tingnan na natin. C over 0.003. This is coming from our tawag dyan, yung similar triangle. Ayan. So as you can see here, sa ating figure, we have two triangles. Diba? So as you can see, same yung ating angle dito, same yung angle dito. So therefore, we can have or we can use similar triangle na concept. Meaning na similar triangle is 0.03 divided by C is equivalent to our, ayan, DT. Ayan, yung malaki natin na triangle. This triangle, ayan. And this one, dt multiplied by or plus 0.03 plus yung nasa baba, which is 80. Ayan siya, 80. Okay, ulitin natin. This triangle, ayan. Diba? 0.03 over C. And this triangle, this height, ayan. Ato. This height, this is our dt. Then, ET plus yung 0.003. Kita niyo ba? Ito siya. Nilagay dito. Ayan, this triangle. So, this angle is the same with this angle. So, therefore, similar triangles. 0.003. Okay? So, ayan siya. C over dt 0.003 plus dt. So, ang ginawa lang dito is cross multiply. So, therefore, nabuo lang ito na formula. Diba? So, ito nilagay dito sa itaas, 0.003 dt. Then, sa baba din, no? Yun lang. No? 0.003 et. No? Strain or epsilon ng ating tension side. So, take note kasi and if we are talking about reinforcing bars, medyo constant na siya. No? Ang ginagamit natin na modulus of elasticity. No? Set of materials, modulus of elasticity, that is our property of our steel for, I don't know, basta modulus of elasticity. Ayan, elasticity niya. Okay, that is 200,000 megapascal. So, if i-multiply natin to, no, ES natin, i-multiply natin dito sa itaas, then i-multiply din natin sa baba ng 200,000 megapascal. Diba? Ayan. That is equivalent to yung 0.003 natin multiplied by 200,000 paki-calculator, that is 600. And then if we multiply yung nasa baba, same pa rin 600. And then ET times ES, ayan. ET, ES, ayan siya. No? Okay, tension, same lang yan siya. Si epsilon T tsaka si epsilon S. Diba? So, that is equivalent to SS. Ayan. So, na-substitute natin siya dito. Then, ET multiplied by ES. Ayan siya. Naging SS. Okay. So, therefore, magagamit natin yan mamaya. Okay ba? So, next is our steel ratio. So, kanina sa ating graph, diba, sabi ko na we need to equal or to balance that one para walang moment. So therefore, our C or compression na force must be equal to our tension na force. So dito po galing yung ating C is equivalent to T. Diba? So with that one, C kanina natin is 0.85 FC prime multiplied by A, that is the height of our compression block, multiplied by B, which is our width. No, haba bang tawag dyan ng ating beam. That is equivalent to AS times SS. Ayan siya. So with that, mandi-derive natin yung mga ginagamit sa mga books na mga formula. Di ba? So 0.85 FC prime, sabi dito doon kanina, yung A natin o yung height ng compression block is equivalent to B prime. Oh, tawag dyan, B prime. Sorry. Beta times C. Ayan siya, beta times C. And then, let natin rho, that is rho, di ba? I don't know. I think that's rho. Yes, that's rho. Rho natin, no? Kagaya lang last time sa ating slabs, rho natin is area of steel divided by BD, no? Or no? Area sa steel natin divided by our base times our depth. So therefore, pag ilipat natin to the other side, ang area of steel natin is equivalent to rho BD. So ang ginamit lang nito, no? So substitute lang natin to the other side. So ayan siya, napalitan siya. So kanina na-discuss natin in determining your C, which is the height of our, ano yan yung C? Yung small letter C, ayan. That is the height of our neutral axis. From the top, papunta sa neutral axis. No? Hindi ibig sabihin na equivalent talaga siya na, and neutral axis natin is nasa gitna. No? Nag-change siya depending upon the situation. So therefore, kailangan natin i-solve si C. So yan si C, pinalitan siya ng this one. Ay, sorry, ito lang. Ito lang pala. Ayan, coming from this one. Okay? So therefore, na-derive to ng mga formula. Diba? So same lang yan. Ito, gamitin mo ito or ito. So next slide, ayan. So here we have our nominal flexural strength. So kasi minsan sinasabi ng ating mga sa board exam na problems or anything na problems na using nominal flexural strength, no? So therefore, pag ganyan, automatic ito na yung gagamitin natin for our moment itself. So as you can see kanina sa ating graph, sa ating figure, diba? We have our compression and tension. So if dito ka mag-moment sa baba, so therefore our nominal moment, yung MN natin is 0.85 or yung C natin multiplied by our lever arm, diba? Because our moment must be created from a point load and a lever arm. So point load natin is yung C multiplied by ating lever arm, which is D minus A over 2. Ayan siya. So D A over 2 or 1/2 is equivalent to 0.5. Baka malito kayo. Yan lang yun. Yeah. I-convert lang siya into 0.5. Okay? So same pa rin if mag-moment ka sa dito sa itaas, therefore T natin is multiplied by D over 2 or D minus A over 2 para makuha natin yung ating MN or nominal. So therefore, kailangan natin si design flexural strength. So si design flexural strength, that is our MN multiplied by our yung ating C. C. Yes, C. C ba to? It is rho. Yes, this is C. Okay. So, nalilito ako sa mga Greek na mga symbols, no? Anyway, so, next one, if, paano pag sinabi ng ating problem na balance strain condition? Ano yung ibig sabihin dyan? So, if our problem states that balance yung ating strain condition, therefore, yung ating strain is balanced. Baliktad ko lang. Ang ibig sabihin po niyan is yung ating Fy ng ating steel, that is equivalent of our Fs. Same lang daw siya. Or ibig sabihin, yung ating ES or yung ating epsilon S is equivalent ng ating epsilon. Therefore, if yan yung sasabihin ng ating tawag dyan, problem, this is our formula. Yung ES natin, yung kanina lahat. Yung FS natin, palitan lang natin yung lahat ng FY. No? Still yields or balanced condition. Ayan siya. So, ito yung mga gagamitin natin ng formula if balance yung ating condition. So, take note kanina, di ba? dP over D, this is applicable, yung dP, iulitin natin yan. Yung D kasi is yung na double layered siya. Tinatawag siyang dP if yung single layered lang siya. So, don't worry, kasi mostly naman ng ating mga problems is single layered lang. So, dP over D, Pag same lang yung D mo, DT at saka yung D mo, cancel out lang siya or maging 1. Okay? So, don't worry about that. Okay? Ayan siya. So, raw natin is equivalent to 0.85 FC prime. Ito yung kanina. Same lang yan siya. Yung ating E is pinalitan lang natin ng yung ET natin tsaka yung FS. Pinalitan lang natin yung standard, which is yung EY tsaka yung FY. Okay. So, ito, nakalagay dito DT over D for single layered na tension bars. So, proceed tayo. So, if we are talking about 2010, lahat naman dito is 2010 yung ating discuss, no? Wala namang 2001. Kanina yung load lang pinakita ko, 2001 yung loads, yung 1.4, 1.7. Tsaka yung mga other natin, mga factors. So, 2010, ET natin is must be, tension control yung section natin if ito yung mga conditions niya. Meaning, yung ating epsilon T is greater than or equivalent to 0.005. C natin is, wait lang, pinan natin. Okay. C natin or yung ating height from the top papunta sa ating neutral axis, that is lesser than or equal to 3/8 dp. Rho natin is lesser than or equal to this one. Then, rho natin is this one. If ito yung sinabi, tension control. Sir, what if, sir, sa isang problem sinabi that the section is tension controlled? Ano yung gagawin namin? So, pag ganyan yung sinabi, class, na tension controlled yung ating section, automatically, ito na yung mga gagamitin mo na formula. So, equivalent mo yan. C mo is magiging ganito, rho mo is magiging ganyan. So, therefore, pag sinabing tension controlled, ito na mismo yung mga formula na gagamitin mo. Okay, how about if sinabi ng compression controlled? Meaning, mas malaki yung kanyang compression itself if i-compare mo sa tension niya. So, pag ganyan, opposite lang siya. Yung ating epsilon T is lesser than equal to sa ating EY. C natin, na compression block, yung ating height papunta sa neutral axis is greater than CB. Basta ito lang yung mga gagamitin mo ng mga formulas if sinabi ng ating problem na compression control. So, rho natin must be greater than or equal to our rho balance. Diba? Fy natin is 415. MPa yung gagamitin natin. Then, yung ating ET, epsilon T must be lesser than 0.002 and C natin must be greater than 0.6 ng ating D or yung ating effective test. Okay, so, ayan, how about if sinabi na allowed yung ating transition zone or section limit? No? So, that is, ito yung gagamitin natin. Nasa transition tayo na zone or section limit if nasa gitna siya sa mga gantong mga values. So, ganyan for checking na yan. Okay. So, next is other equations. Ano yung magagamit natin sa ating mga solving mamaya? So, coefficient of resisting moment, that is our Rn. Diba? Na-discuss natin ito sa one-way slab. So, medyo familiar na to. Ito yung palaging ginagamit. Pero you can also use this one. Pero medyo mahirap to gamitin. No? Masakit sa mata. Kaya, minsan, ito na lang talaga yung ginagamit natin na resisting moment, yung Rn. So, reinforcement steel ratio natin, no, that is Rho. Diba? Rho is equivalent to AS over BT. Then, same pa din, no? Diba? Sa ating slab, if you have your Rn, you can use that one or you can substitute that one to ating Rho is equivalent to 0.85 FC prime over Fs. Or, nasa slab natin, if it yields, this is our Fy. No? Same naman siya. Then, 1 minus the square root of 1 minus 2 Rn over 0.85 FC prime. Okay, so I think that's it for the formulas or the derivation. I hope that I did derive it very well. Pero don't worry, marami naman ding video sa ating YouTube, kagaya ng sinend ko sa inyo, on how to derive these formulas. Diba? So, next video natin is examples of our one-way or singly reinforced na big. So, thank you and goodbye.